Hello everyone, welcome to Circuits and Network class. Today we are going to deal with problems related to resistors, inductors and capacitors and how to solve them using the Laplace transform. Okay, so first we are going to see how you can transform the resistor into the S domain. Okay, so if you have a resistor, the resistor will always be converted into the S domain. You can draw the resistor from the time domain to the S domain by drawing a resistor itself, and the value will be R itself. There will be no change in the value of the resistor. Okay, I'm not going to move into the derivation. Okay, similarly, if you look at an inductor in the S domain, if you have a simple inductor over here, when you are changing it to the time S domain, when you're converting it into the S domain, you can see over here the current is entering in this direction. Okay, you can replace the inductor with an inductor in series with a voltage source. Okay, the inductor will be in series with a voltage source, and you should also check the polarity. You have minus first and then plus, and the value of the inductor is also changing. Here it was simply L, whereas if you're converting it to the S domain, it will be L into S or S into L. Both are the same. LS or SL, both are the same. And the value of the voltage source will be given by L into I0, where I0 is the initial current of the particular inductor. If there was an initial current flowing through the inductor, that will be I0. Or you can convert it into an inductor in parallel with a current source. Okay, you can convert in this manner also, and the value of the current source will be I0 by S. Similarly, if you take the case of a capacitor, the capacitor can be converted into a capacitor in parallel with the current source or a capacitor in series with a voltage source. You just look at the direction, polarity of the voltage source, it is first plus and then minus. And the current source direction is upwards. We can also just check the magnitude. The magnitude of the capacitance is 1 by SC. Okay, in both the cases, the magnitude of the capacitance is 1 by SC, and you can also note the value of the voltage source. It is V0 by S, and that of the current source, it is C into V0. Okay, so these are the transformation of your resistor. Okay, that is the resistor is converted into R itself. Your inductor, it is converted into a inductor in series with a voltage source or in parallel with a current source. These are the values L into S or L into I0. And you have the capacitor, it is converted into capacitor in parallel with current source or a voltage source. You must always check the polarity. Polarity of the capacitor and that of the inductor are opposite. You can see here it is minus plus, here it is plus minus. Okay, and the value of the capacitor is 1 by SC and V0 by S. So this is just something that I have drawn in a tabular form. Okay, you can see over here the time domain and the S domain. I have only drawn the inductor or the capacitor in series with the voltage source. This is the conversion which we are commonly using. Now, let us just see one more point before we move on to the problems. If your inductor, it was not connected to a voltage source, you can see over here the switch is open. In that case, your inductor will be acting as an open circuit. And suppose your inductor was connected to a voltage source or a supply for a long time. Okay, if it had reached steady state. Okay, the term steady state is important. If it had reached steady state, then the inductor will act as a short circuit. In the case of the capacitor, it is completely the opposite. If your capacitor is connected to a particular voltage source, it will act as a open circuit. Okay, if it was in steady state, it will act as an open circuit. Now let us do two problems related to these topics. Okay, now in this particular question, the switch is moved from position 1 to 2, and we are assuming that in position 1 it was in steady state, and at t equal to 0 the switch position is moved to position 2. What will be the value of I of t? Okay, we need to find out the value of I of t. Now we are in all of the cases, you have to start with the case where the switch was not switch was in the first position. Okay, first position, that is position 1. Here it is position 1. The initial position is position 1, and you can see if you are drawing the circuit, if you are redrawing the circuit, it is not connected to the 1 ohm resistor at the bottom. So you have the 1 ohm resistor over here. Okay, this resistor is there, and then you are having an inductor. And this is 10 volt, 1 ohm, 1 Henry. Now we are assuming, since they have not told anything, we are assuming that your inductor was in steady state at this time. And you can see it is connected to the voltage source. So what will you replace the inductor with? You will replace the inductor with a short circuit. And here your initial current will be flowing through the inductor. And what will be the value of I0? That is the value of the initial current. What will be the value of the initial current? That will be V by R. 10 divided by 1, that is 10 amperes. So now you have got the initial current flowing through the particular inductor. Now you need to find out the current I of t when the switch is moved to position 2. Now when the switch is moved to position 2, you can just redraw the circuit. You have resistor, inductor, and then again you have a resistor. So this is 1 ohm and 1 Henry, and this is your current I of t. Now what are you going to do? You are going to transform your circuit to the S domain. You are going to transform your circuit to the S domain. So the resistor will be resistor itself. Here you are having resistor itself. And instead of inductor, you will be having inductor in series with a voltage source. Voltage source will be present only if there is an initial current. Now you already have an initial current over here. That is why you will be having a voltage source with minus first and then plus. Okay. And what is the value of the resistance? You have 1, not ohms, you have 1. I'm sorry. Minus plus. You should not write the unit while transforming. That is 1, 1. And here it is L into S. What is the value of L? The value of L is 1. Right? So 1 into S will be S. And what should be the value of the voltage source? The value of the voltage source is LI0. So you should give 1 into I0, that is 10. And what will be your current flowing over here? It is I of S. Okay, I hope it is clear. Now you can simply apply the mesh analysis. You can just simply apply the mesh analysis. You will get 10 minus I of S minus I of S minus S. You should consider while applying the mesh, you take the inductor as a normal, when you are considering a normal resistor, how will you take that way itself? S into I of S is equal to 0. Now you can find out I of S from here. I of S is equal to 10 divided by S plus 2. And now you can apply the inverse Laplace transform. And you will get the current I of t. And you will get I of t is equal to 10 is a constant. What is the Laplace transform of e raised to at? Laplace transform of e raised to at is Laplace transform of e raised to at is 1 by s minus a. So if it was e raised to minus at, be 1 by s plus a. So here you have 1 by s plus 2. You can write it as e raised to minus 2t. Okay, 1 by s plus 2 is e raised to minus 2t. And you have got the current I of t. Okay, so the procedure is first you should take the first case. Okay, take the first case and find out the initial current. Here you should not do any transformation. And then you take the second case. You have already got the initial condition. So you simply have to transform the circuit and then you can apply the mesh or node and then find out the inverse Laplace transform. Similarly, we can do a problem with capacitors. We can do a problem with the capacitors. Now in this case again you can take the case for t equal to 0 minus. Okay, t equal to 0 minus, your switch is in position A. So in position A you can just redraw the circuit. Now you are having a capacitor, it is in position A for a long time. That means you should replace the capacitor with a open circuit. And this will be your VC of 0 minus. Here you have 1 ohm and here you have 10 volt. Now, you need to find the voltage VC of 0 minus. Is there any current flowing through the circuit? No, right? Because it is an open circuit. Because the capacitor, we are replacing it with an open circuit. That is why no current is flowing through this particular circuit. So that means there is no voltage drop across the 1 ohm. And the voltage across this capacitor will be same as 10 volts. So VC of 0 minus, or you can call it V0, that will be 10 volt. Now you can take the case for t equal to 0. You can redraw the circuit. It is in position B. In position B, what is going to happen? You have your capacitor. You have your 6 farad. You have your 3 farad. You have your 1 ohm. You are going to transform the circuit. You can transform the circuit. Resistor will be with resistor self. What was the initial voltage of the 3 farad capacitor? Is it connected to any source over here? You can see that your 3 farad capacitor, it is not connected to any source. So that means for this particular capacitor, the initial voltage, I will call it V0 dash, it is 0. So if you are transforming the circuit, for the 3 farad you do not have any initial voltage. That is why it will not be having a voltage source in series with it. Only if there is an initial condition, only then you will get the voltage source. And the 6 farad capacitor, it is having an initial voltage, so you can replace it with a capacitor in series with a voltage source. The value of the resistor will be the same. Value of the capacitor is 1 by Cs. So 1 by 3s, and here it is 1 by 6s. What about the value of the voltage source? It is V0 by S. So you have V0 is 10. 10 by S. Now you can just find out the current I of S. And here you are having Vc of S. Here you have the current I of t and Vc of t. You can simply apply the mesh analysis. That will be 10 by S minus 1 by 6s into I of S minus I of S minus I of S by 3s is equal to 0. Now you can solve for I of S. I of S is equal to 10 by S divided by 1 plus 1 by 6s plus 1 by 3s. So that will be 10 by S divided by 1 plus, here I think LCM will be 6s. So that will be 1 plus 2, that will be 3. Okay, 1 plus 2 will be 3. Here will be 1 by 2. So that will be 10 by S plus 1 plus 1 by 2s. Okay, now you can just multiply the numerator and denominator by S. Okay, I'm just going to multiply the numerator and denominator by S. So that will be 10 divided by S plus 1 by 2. Okay, 10 divided by S plus 1 by 2. Now what you have to do, the next step is you need to find out the inverse Laplace transform. You find out the inverse Laplace transform. If you find out the inverse Laplace transform, it will be I of t is equal to 10 is a constant e raised to minus t by 2. Then you also need to find out the voltage Vc of S. Vc of S, how do you find the voltage across a particular element? It is the impedance into the current. Now, you have already got I of S is equal to 10 by S plus 1 by 2. So, what will be Vc of S? Current through this capacitor is I of S. So, Vc of S will be, what is the capacitance value? 1 by 3s. 1 by 3s into I of S. Right? What is I of S? I of S, you have got it over here, 10 by S plus 1 by 2. 10 divided by S plus 1 by 2. So you can write it as 10 by 3 divided by S into S plus 1 by 2. So here you need to apply the partial fraction expansion. That will be A by S plus B by S plus 1 by 2. You can find out the value of A and you can find out the value of B, and then you can find out the inverse Laplace transform. How do you find out the value of A? You can do it in two methods. I am more familiar with doing it in this method. You take the denominator of A. Denominator of A is S. You multiply it with the whole original polynomial. Okay, your whole original polynomial is 10 by 3 into S plus 1 by 2. So that is 10 by 3 divided by S into S plus 1 by 2. You do the cancellations at S equal to, what will be the value? What is the denominator of A? It is simply S. So it is S equal to 0. And you substitute the value of S equal to 0. So it will be 10 by 3 divided by 1 by 2. You will get it as 20 by 3. How will you get the value of B? You take the denominator of B, that is S plus 1 by 2 into the whole function. 10 by 3 divided by S into S plus 1 by 2 at S equal to. How will you find it out? You take the denominator, s plus 1 by 2 equal to 0, that will be s equal to minus 1 by 2. So you have to substitute s equal to minus 1 by 2. You do the cancellation first, and then wherever you find out s, you substitute it by minus 1 by 2. So that will be 10 by 3 divided by minus 1 by 2, that will be minus 20 by 3. And now you can just substitute it over here. What will you get? 20 by 3 by s plus minus 20 by 3 divided by s plus 1 by 2. Okay. Now you find out the inverse Laplace transform. Vc of t is equal to, what's the Laplace transform of 1 by inverse Laplace of 1 by s? It is 1. So your constant will be there, minus 20 by 3, 1 by s plus 1 by 2, e raised to minus t by 2. Or you can take 20 by 3 outside and you will get 1 minus e raised to minus t by 2. This is your final answer. Okay, so I hope some of the problems based on solving resistive, inductive and capacitive circuits using Laplace transform and transform circuits, I hope it is clear. Problems on RLC RLC circuits I have already uploaded in our group. Okay, so thank you. Please stay tuned for more videos.